Hello, this is Jovial, and let's discuss exocets. These are an exocet belongs to a class of related techniques that can be generalized pretty heavily. But in this video, I will just be showing the basic junior exocet, and we'll leave it to you to generalize further if you'd like, or if desired. Feel free to contact me, and I can provide further examples. Okay, so let's get started. The principal idea of an exocet, at the risk of sounding patronizing, has to do with the fact that in each column of the grid, or row, of course these can be rotated, but I find it easier to view with columns because you're reading left to right. It's based around that each column has the digits 1 to 9, one each. So in these three columns, 1 would have to appear 3 times. The digit 1, for example, would have to appear 3 times. So if we were to do something like this, where we have these, which are given as non-1 digits, then outside of this, basically we have to place 3 ones in these 3 columns total. And because we can't repeat digits in rows, each of those ones has to be in a different row. So we know that at least one of the ones is in this group of highlighted cells, because if it isn't, we would only have 2 rows to place 3 columns worth of ones. Okay, so how does an exocet grow from here? Well, you can set this up such that, let's make this an 8. Now we have to have a 1 and a 2 in this group of cells. Or maybe we make this a 9, and now we have to have at least 1 1, at least 1 2, and at least 1 3 in this group of cells for the same reason. So from there, we can sort of draw out what the conditions for a basic junior exocet are. Exocet terminology, by the way, is kind of bad. Junior and senior exocets are terrible names, but that's what they've been called historically, so that's what I will continue to call them. Let's do and see if I can remember how to set this up. This will be a 9, this will be 5, this will be 7, and this can be 5 as well. And I'll go ahead and do one, 4, and 3. And let me check if this has solutions. It does, which is good. Let me check true candidates. Aha! Yes, so I haven't actually fulfilled the conditions for exocet yet, but I shall get into that. If I place a 6 here and an 8 here, do we still have solutions? We do, okay. So an exocet here is based on, in this example, is based on these 3 columns. The digit 1, I will just color them as they appear. The digit 1 outside of this middle band can only appear in 2 rows. I'll color it yellow. The digit 2 outside of the middle band can only appear in 2 rows. The digit 3 outside of the middle band can only appear in 2 rows. And the digit 4 outside of the middle band can only appear in 2 rows. I'll color this red. Okay, so now we know in these cells we have to have at least 1 1, at least 1 2, at least 1 3, and at least 1 4. Because if we don't, we'd only have two rows to place 3 columns worth of 1s, 2s, 3s, or 4s. So these 2 cells right here, I'll color them purple, I suppose. C5, 6, 7, 8, and 9, which means they must be from 1, 2, 3, 4. Now these 2 cells are not in gray, but they have to appear in gray. This is because we have to have a 1, 2, 3, and 4 in gray. So these 2 cells see these 2 gray cells in the box, and these 2 gray cells in the row, which means that these 2 cells are exactly equivalent to these 2 cells. And that is sort of the basic idea for an exocet. You can generalize it such that the target cells here are in different places in the grid rather than in just the one band. You can generalize it such that the houses here aren't all columns. You could have 2 columns in a box, etc. But that is sort of just the basic idea. You can also have situations where you have sort of more than one at once that both sort of fill in all of the remaining possible sort of make it so that there are no degrees of freedom, as in here I said we have to have at least 1, 1, at least 1, 2, at least 1, 3, and at least 1, 4. But you could have situations theoretically in which you can only have exactly one of each. And in those situations, these cells here that I will color in dark green would no longer be able to contain the digits 1, 2, 3, and 4, because all of the it has to all be contained in these cells, which if that's confusing, I will leave it to you to figure out why that must be the case. But hopefully this video was helpful and helped demystify this technique that a lot of people seem to find scary. Thanks.